Welcome to the Unit 8 test review. All right, so I'm going to get started. So number one, we are simplifying this rational expression. To simplify a rational expression, you first look at the numerator and factor it. In this case, we'll always look at the greatest common factor. What's the greatest common factor between 5x cubed and 45x? So 5 and 45, we can divide them both by 5. X cubed and x to the first. Always amongst variables, the greatest common factor is the smallest of the exponents. So we're going to divide both by 5x. 5x cubed divided by 5x is x squared. And 45 divided by 5x, 45x divided by 5x is negative 9 or minus 9. All right. After you take out the greatest common factor, that is not totally factored. That just takes out the greatest common factor. Inside of the parentheses, we have a quadratic yet. Whenever you have a quadratic, you have to be aware that there could be more factoring that we can do. I see a binomial. I see a quadratic that's a binomial, and there is a subtraction in the middle. Can I square root both terms? Sure can. That tells us it's a difference of squares. So we have the 5x on the outside, that's the factor, and the square root of x squared is x. So I'm going to write up two binomials, x, and the square root of 9 is 3. One of the binomials is positive, one's negative. At this point, we look at x plus 3 and x minus 1, or x minus 3, sorry, and we have exponents of 1. Those are linear binomials. There is nothing else to factor here. Looking at our denominator. Denominator, we have 10x squared, that's a monomial. Nothing to factor there. We have x plus 3. That is nothing to factor there. That is already a linear binomial. There's no greatest common factor. And x minus 3. That is a linear binomial. There's no greatest common factor. At this point now, I'm going to look at all of the terms, or all the factors. I have 5x, that's a monomial, and I have 10x squared. I'm going to simplify this. 5 over 10, 5/10, that fraction reduces down to 1 over 2. Divide numerator and denominator by 5. We then also can simplify the x and x squared. We have 1x in the numerator, 2 in the denominator. Simplify, eliminate 1, and 1 was left. We have x plus 3 in the numerator as a factor. We do have an x plus 3 in the denominator. Those will simplify with each other to anything divided by itself is 1. So I always put the 1s there. And lastly, we have x minus 3 over x minus 3. Those also simplify to 1. Let's clean up what we have here. So we have 1 times 1 times 1 is 1 in the numerator, over 2 times x times 1 is 2x in the denominator. Looking at number 2, doing the exact same thing. Oh no, we're not. This is a division. We're going to keep the first fraction the way it is. So I'm going to change it to a multiplication problem. So it's much easier for us to change it to multiplication and multiply by reciprocal. So changing numerator and denominator, flipping them. I'm going to factor each numerator and denominator. So the greatest common factor here is 5x. Divide the first term by 5x and the last term by 5x. The denominator, x squared minus 6x minus 16. We have a is 1, so it's what two numbers multiply to negative 16 that add up to negative 6. That's negative 8 and positive 2. Nothing to simplify or nothing to factor with x minus 5. That's a linear binomial, no greatest common factor. And we have 5x in the denominator. That is a monomial, so nothing to simplify there. Now let's look at our numerators and denominators. We have 5x. There's a monomial in the denominator. Yes. Doesn't have to be exactly the same. No, it does not. In this case, it is 5x. And with multiplication, you really, it's like there's all this, you're going to treat this as one fraction. The reason why you can do that is with multiplication of fractions, you multiply the numerator and you multiply the denominator straight across. Really what that's doing is we have 5 times x minus 8 times x minus 5. And then in the denominator of x minus 8 times x plus 2 times x or 5x. So really, any numerator and any denominator can be simplified with each other. So 5x divided by 5x is really going to be 1. Same thing divided by itself. We have also x minus 8 and x minus 8. Those are the same binomials. And that is it. In the numerator, we have x minus 5. The denominator, we have x plus 2. Number 3. Multiplication, don't have to change it. Look at your numerators. X minus 4 cannot be factored. Here, let me do this. We have 3x squared minus 4x minus 4. No greatest common factor in that denominator, so I do a times c. What two numbers multiply to negative 12 that add up to negative 4? And that would be negative 6 and 2. Because the a is greater than 1, we need to use the Punnett square. So you have a top left, c bottom right. Greatest common factors of each row. And there is our first denominator. There's our numerator is x minus 4, denominator is x minus 2, 3x plus 2. We need to factor the next numerator, 7x squared minus 19x plus 10. No greatest common factor, so we do a times c. This is a quadratic. Think about what two numbers multiply to 70 that add up to negative 19. It's negative 15 and negative 4. Yes, they'll add up to negative 19 and multiply to positive 70. It took me a while to figure that out. I did that in class, so I didn't just come up with it off the top of my head now. A term top left, C term bottom right, negative 15x, negative 4x, greatest common factor, 5, greatest common factor of the first row, oh no, it's not. My bad. It is not negative 15 and 4. My bad. What is it? So we have it's 14 and 5. My goodness, that's negative 14 and negative 5. Aha, that's it. There we go. So we have x minus 2 and 7x minus 5. My bad. And the last denominator, at least this one's a little easier to do, I hope. 5x minus 20. It's a linear binomial, so the greatest common factor, is there one? Yes, it's 5. Divide each term by 5. Get x minus 4. All right, finally, everything is factored. Now let's look at numerators and denominators. We have an x minus 4 and an x minus 4 in the denominator. With multiplication, you can simplify across fractions. X minus 2 divided by x minus 2 is 1. And that is it. There's no other binomials that are identical with another binomial, and there's no monomials that can simplify with monomials. So we have 1 times x minus 5 is, or 7x minus 5 is 7x minus 5. 1 times 3x plus 2 times 5 times 1. I'm actually not going to multiply it out. I'm just going to write the 5, the monomial first, and then 3x plus 2. Number 4. All right, we got the division, so we're going to have to change. Keep the first fraction the way it is. Change to a multiplication and you're multiplying by the reciprocal. So you're flipping the second fraction. Looking at your first numerator, x squared minus 49. Can we factor that? Sure. Sure it can. A is 1. It's a binomial, and you can square root both terms. So it's going to be x squared of 49 is 7, x plus 7, x minus 7. The first denominator looks like the same exact thing. Square root of both terms. If it's a subtraction, this is called the difference of squares. X minus 5, x plus 5. The plus and minus don't matter where they are. The numerator is x plus 5. And there we have nothing. It's a linear binomial. So nothing there to factor. So that's just x plus 5. And last denominator, looks like we can factor the greatest common factor out first, which is 3x, and we have x plus 7. Let me rewrite what we have. We have x plus 7 is the first numerator, times x minus 7. First denominator is x minus 5, x plus 5, times x plus 5, over 3x times x plus 7. Looking at our numerators, we have an x plus 7, denominator x plus 7, I'm going to write 1s, x plus 5, x plus 5, simplify, that's the same thing divided by itself. And that is it. Rewriting what we have on the numerator, we have 1 times x minus 7 times 1 is x minus 7. The denominator, we have 3x times x minus 5. Moving on. Number 5, we need to figure out which one of these expressions so let's look at the denominator, we have to look at each one of these answers, and we have to simplify them. So we're going to need a factor each. So the numerator on A is 1. Actually, looking all of them, the A's are all 1. So that tells us we can do what two numbers multiply to C that add up to B, which is going to make things a little faster. So what two numbers multiply to 8 that add up to 6? And in the denominator, what two things multiply to negative 12 that add up to 1? Oh, positive 1. So it's got to be positive 4 and negative 3. All right, looking at that, can we simplify anything? Yep. X plus 2, x minus 3. Yeah, that's one of our answers. Don't get caught off guard. It says select all that apply, so we've got to keep going. It could be every single one. Next, we have C is negative 2, the B is negative 3, so we do what two numbers multiply to C that add up to B, so it's negative 2 and negative 1. And the denominator, what two numbers multiply to negative 3 that add up to positive 2, that's x plus 3, x minus 1, simplify, x minus 2, x plus 3. No, close, not quite. C, we have what two numbers multiply to negative 8 that add up to negative 2, minus 4, plus 2. The denominator, what two numbers multiply to positive 12 that add up to negative 7? It's negative 4 and negative 3. And anything to simplify? Yep. X plus 2, x minus 3, yes, good. And lastly, numerator is going to be two numbers that multiply to 4 that add up to 5, so 1 and 4. And the denominator, what two numbers multiply to 12 that add up to 7, 3 and 4. Simplify, nope, not the same. So it's just A and C. And number 6, all right, we are factoring. Factor the numerators. First numerator is a monomial. We're not going to nothing to factor there. You could break it up into 2 times x times x. It's not going to be helpful. Denominator, you're going to A is 1, B is -1, C is -42. Two numbers multiply to A, or to C that add up to B. So now our next numerator, we have what two numbers multiply, since our A is 1, what two numbers multiplied into positive 21 that add up to -10? That'd be 7 and 3 with negatives on them. So x minus 7, x minus 3. Last denominator, x minus 3, that's a linear binomial. No greatest common factor, so that is it. If you want to put parentheses around it, you certainly can. There's no need to, but you can to make it feel like it's part of the group of factors. Now we're going to look at any numerators and denominators. Since we have multiplication, we can go across any numerator and denominator, and they can simplify like the x minus 7s. X minus 7 divided by x minus 7 is 1. X minus 3 divided by x minus 3 is 1. Do you need to put the 1s there? No. But if there's nothing left in the numerator, you're going to want to have the 1s there, so you know that there actually is a 1 in the numerator. In this case, we have 2 times x squared times 1 is 2x squared. And 1 times x plus 6 times 1 is just x plus 6. Well, that happens to be C. Perfect. Moving on, last problems. All right, I put this as number 7 because it shouldn't be number 1. But looking at common denominators now, there's nothing to factor these monomials. Between 7 and 4, a common denominator would be 28. So I need to multiply the first fraction by 4, the last fraction by 7 over 7. Remember, we're multiplying by something that's equivalent to 1 doesn't change the value of the denominators. 4 times 7 is 28, 4 times 7 is 28. So we're just going to look at the numerator. 4 times x minus 10 equals x times 7. So it's 4 times the binomial x minus 10, so I put in parentheses, and x times 7, those are monomials, so it's just 7x. Distribute the 4. And now we have like terms across the equal sign, so we're going to change the operation. Divide by 3. And you get negative 40 over 3. Next, number 8. What I'm going to count as number 8. Looking at our denominators, we have 2x squared, and 2x. Your common denominator should be 2x squared. We can multiply this middle term by 2x, the last term by x over x. That gives us, if you just look at our numerators, 3 plus 2 times x plus 2 equals 1 times x. Remember, this is a binomial, so it's 2 times both terms. Instead of doing it the right away, we just put parentheses so then we know to distribute. 2 times x plus 4 equals x. All right, we have like terms. 3 plus 4 is 7. And it doesn't matter which way we go. You can subtract x and then subtract 7 to the opposite side. So we're really just moving terms around. Because 2x minus 1x is a positive x, or positive 1x equals negative 7. Number 9. Here we can't just easily look and see what we have for denominators. We have an x minus 7, that's factored. X squared minus 49, that is a difference of squares, which is x minus 7, x plus 7. We already have stuff in common. X minus, no, x minus 7. But we don't have an x plus 7 in common, so we need to multiply by x plus 7. Multiply the numerator and denominator by that. Drop the denominators. Oh, we don't have to multiply anything on the last one. That was wonderful. Distribute the 2. And we get x equals 14. And our last problem. Nothing to factor, they're all monomials. Greatest common or common denominator that we can get here would be 5x squared. You gotta think about what could we multiply the first fraction by to get 5x squared? 5. What can we multiply the middle fraction by to get 5x squared? X squared. And so now we have 5x squared, 5x squared, and 5x squared. Perfect. Let's look at our numerators now. 5 times 1 is 5, minus 1 times x squared is just minus x squared, equals 1. So we have 5 times 1 is 5, minus 1 times x squared is x squared, equals 1. For this, I see a quadratic, so we can solve, or I see a quadratic, but I only see one variable in all of my terms. So I can solve for that variable. I'm going to move the x squared so it's positive. And the reason why I moved it to make it positive, because now we're going to square root and square root. When you square root a positive, it comes out a lot nicer. Square root of 4 is 2, so positive negative 2. There are two answers there.